How well did our design meet our project specifications?
Our design properly met the project specifications as we had all the mechanisms we needed to complete all the tasks. Did our design perform how it expected to? Our robot didn't perform as we wanted it to for the individual competition. While each performance test was easy to put together, putting all together the performance test for our individual competition was a complete different animal. It came with many inconsistencies and problems with our mechanisms, as well as positioning the robot that made it really hard for us to complete the individual competition by the deadline. What were the strengths of our design and what should remain the same going into the final competition? The strengths of our design was really found in the components with multiple functions on the robot. Because of the multiple functions on certain components, it decreased the number of variables to account for when we tried to improve the consistency of our robot. Our design will remain mostly the same going into the final competition, except for a few minor tweaks. For instance, the revolver arm could sometimes hit the hot plate when it was flipping it and get caught. And that's a big problem that we've been having this week so far with our tests as well. So we plan on probably shortening the revolver arm, as well as the ticket slider arm, which has been getting caught, and that caused it to steer away from its path. How can the design be improved for the final competition? Our robot was getting a lot of problems last week, and as a result, we were not ready for the individual test. First of all, the big change that we need to make is to make sure that we get enough time to test. And we've done that this week so far by moving our testing schedule up earlier in the week to try and get the bulk of our testing done in the first half of the week before people start piling up toward the final competition. Second of all, we need to make big software changes. A big problem that the robot was running into was that it was literally running into everything on the course and getting stuck on each mechanism was getting stuck on everything, and everything was getting stuck on each mechanism, and that just caused our robot to completely stop. And as a result, the team had to use a kill switch during the individual competition. But a good way to change that is to change the software so that the robot doesn't get stuck on anything, but also to add a failsafe just in case that it does get stuck, to time out and move on to the next task. More specifically, we saw this in the ticket slider of the robot. While moving up the ramp, the robot was able to turn to the sink and deposit the tray perfectly, but every single time on its way back to the ticket slider, it would get stuck because it would move too close to the ticket and run into the entire ticket structure. We plan to fix this by removing RPS. By making shaft encoding more consistent, we hope that it'll minimize the variability from course to course, and it won't get the robot stuck on one course while moving on another course. In terms of hardware, like I said before, we're going to plan on shortening the revolver for the burger arm so that it won't get stuck on the hot plate when flipping the burger. Overall, the problem was in our execution. While our design was ideal in fulfilling each task on the course, the execution was difficult because with all the moving parts, by putting the different performance tests together for the individual competition, if one task went wrong, then all the other tasks went wrong, and the positioning of the robot was super important and was something really difficult to get down with the limited amount of time and testing that we had.